Okay, we're going to construct arithmetic sequences. An arithmetic sequence is when the difference between consecutive terms is constant. When the difference between consecutive terms is constant. So I'm going to give you an example. Consecutive, that means one right after the other, is constant. So an example would be something like 3, 6, 9, 12, 15, and so on. The common difference we call D, and it is the amount you add to get to the next term. So I would add, in this case, 3 to get from one term to the next, 3 to get from one term to the next, 3 to get to one term to the next, 3 to get from one term to the very next. And that constant means that that 3 never changes. It's always add 3 to the previous term. So here we have a table of values, and we want to write a recursive rule and an explicit rule. So we're going to be writing two rules. One is a recursive rule, and the other one will be an explicit rule to model the data. The table shows the monthly balance in a savings account with regular monthly deposits. The savings account begins with $2,000 and $500 is deposited each month. We're going to start with the recursive rule. Remember, recursive is when you have the rule that depends on the previous term. So the recursive rule says, define your first term, which is 2,000, and then, comma, write your rule. The value of the nth term is equal to the term before it plus 500. And that's going to be true whenever n is greater than or equal to 2. The reason why n is greater than or equal to 2 is because, remember, this is the second term, and we already have the first term. So we would not be able to say n is greater than or equal to 1 because the first term is already defined. So we're just defining every term after the first term. Therefore, when n is greater than or equal to 2. So every term after the first term would start with the second term, then the third term, fourth term, and so on. So this is our recursive rule right here, this whole thing. I need to use yellow. This whole thing is our recursive rule. Now our explicit rule is a little bit more challenging. The explicit rule allows us to find any term value in the entire sequence without knowing the term before it. So I can figure out f of n of any value of n. You're going to take your first term and you're going to add your difference and multiply that difference times n minus 1. So this is the value of your first term. And then your common difference d. This is your common difference d. And then this is just an expression, n minus 1. Now we can simplify this by saying 2,000 plus, and we can distribute. 500 times n is 5, that should be a 2,000. Plus 500 times n is 500n. 500 times negative 1 is negative 500. So f of n is equal to 2,000 minus 500 is 1,500 plus 500n. And yes, some people would write that f of n equals, that's an n, f of n equals 500n plus 1,500. They'd put that constant at the end. This right here is your explicit formula, so I'm going to highlight that in green for explicit. We're going to try another one. The table shows the monthly balance in a savings account with regular monthly deposits. We want to find the recursive and the explicit. So the recursive starts with defining f of 1. Then separate it by a comma, and then we can say every term after the first is defined by f of n equals, what do we add to get from one term to the next? We're going to add 1,000. So we'll take the previous term plus 1,000. And that's going to be good for the second term and forward. So remember that this means the term before. And that's because of this f out in front. So it's a name of a function. It's not the distributive property. The explicit rule says, hey, you can find any term that you want. And we're going to start with the first term plus the common difference of 1,000 times n minus 1. I'm going to distribute that 1,000 and I'm going to simplify. 5,000 plus 1,000n minus 1,000. So I have 1,000n plus 4,000. That's my explicit rule. Now it's your turn. Go ahead and press pause and try this one on your own. You may need to go back and watch the video a couple of times. If you're not sure, you might want to go back and watch that video, slow down, make sure that you understand where each part is coming from, and then come back and give this one a try. Okay, here we go. So first, to find the recursive rule, we first define our first term. So f of 1 equals 155. The second part after the comma is the actual recursive portion of the rule where it says the value of the nth term is equal to the term before it minus 14. And that's because we're adding negative 14. And then this is going to occur for the second term forward. So that's where the n is greater than or equal to 2 comes in. Now our explicit formula says f of n equals the value of the first term minus 14, because we're subtracting 14 to get from one term to the next, times the quantity n minus 1. We distribute the negative 14 and we get 155 minus 14n plus 14, which gives us negative 14n plus 165. Now, the general recursive rule, let's use a pretty highlighter on this one. The general recursive rule is what we have just been doing. And the general explicit rule is also what we've been doing. So now, if you were a little confused, you can come here and you can use these wonderfully defined rules. Very, very nice color pink right there. Okay? So write a general recursive and general explicit rule for each arithmetic sequence. Now notice that the general explicit rule is not going to combine like terms. Look at this in yellow. It's not going to distribute and combine like terms. So this is going to make this a little bit easier for us, less time consuming. So the general recursive, we start with what f of 1 is. F of 1 is 100, separated by a comma, and then f of n is equal to the common difference added to the previous term. So the previous term is f of n minus 1, and the common difference in this case is plus a negative 12. So it would be minus 12, minus 12. So minus 12. And that's going to be good for, and you can write it here with a comma, a semicolon, or you can write for all of n is greater than or equal to 2. The general explicit rule starts with f of n equals the value of the first term, which is 100, plus the common difference, which in this case is a negative 12, so minus 12, times the quantity n minus 1. This is not a definition of a function. This is actually the distributive property. So we're going to distribute that negative 12 if we were going forward. However, they told us to keep it just like it is. And look at what I'm doing. What am I doing? What am I doing? Please don't laugh. Okay. There we go. So there's our general explicit. So I'm going to highlight that in yellow. There's our highlighted in yellow. Butamus. And we'll highlight this other one in blue. So there's our general recursive. Okay, let's do another one. 0, 8, 16, 24, and 32. We're going to need to know how we get from one term to the next. That's add 8, add 8, add 8, add 8. That's a constant common difference. Therefore, D equals 8. Our first term is 0. So for our general recursive rule, we're going to have f of 1 equals 0, and then f of n is equal to f of n minus 1 plus 8. And that's going to be for n is greater than or equal to 2. It's a bit sloppy. So let's make it better, because we can be better, right? F of 1 is 0. F of n is equal to f of n minus 1 plus 8. And that's true for, see how I like to put that? I like to put that comma because it saves me some room. That is true for n is greater than or equal to 2. Now our general explicit says f of n equals the value of the first term plus the common difference times n minus 1. And because it wants us to leave it just like that, I'm going to leave it exactly just like that. But if the answer key has, or if a multiple choice item, let's just say it was a multiple choice item, had it simplified, I feel fairly confident that you can distribute the 8 and combine like terms. So what is the recursive rule for the sequence f of n equals 2 plus negative 3 times n minus 1? And how do we know? Well, what is this 2? What does this negative 3 mean? Well, the 2 is the first term, right? It's the value of the first term. Value of the first term. So that's f of 1 equals 2. What's this negative 3? Well, that's your common difference d. So I would put comma, f of n equals f of n minus 1 minus 3. And that would be for all of n is greater than or equal to 2. How do we know? Because we can read the formula. Okay, your turn. Write a recursive and an explicit rule for the arithmetic sequence. And when you come back, press pause. When you come back, the answer is going to be right there waiting for you. Okay, so we're back. So if we're ready for an answer, we are indeed ready for an answer. Our recursive rule I labeled as R, and it is f of 1 equals 6. F of n equals f of n minus 1 plus 10. For n is greater than or equal to 2. And our explicit rule could be f of n equals 6 plus 10 times the quantity n minus 1. Or we could have simplified it and said f of n equals 10n minus 4. And in the next video, we're going to conclude this unit with modeling.